So now that we know how to use percentages to calculate costs and amounts, we're going to look at a problem that is expressed like this. So suppose we have a pair of shoes that originally cost $80, and then its price is increased by 10%, then by 15%, and then by 8%. And we wanted to find what is the latest cost of the pair of shoes. Now, in this problem, we're actually going to have 3 consecutive increases. So in order to do that, there are 2 ways that we can approach this. We can take the original amount, and what we're going to do is we're going to multiply that by basically this. So we know from the last video that if we want to increase the price, we're going to grab 1, and we're going to add the decimal that corresponds to that percentage. So that's 0.1. So that's going to be 80 times 1.1. And that should come down to $88. So this would be the new cost or the new price of the shoes after it has been increased by 10%. And then this same amount is going to be increased by 15%. So we can grab 88. We're going to multiply by 1 plus 0.15. So that's 88 times 1.15. And that's going to be equal to 101.2 or $101.20. And the final time it is increased, we're going to grab the same value from before and increase it by 8%. So we're going to grab 101.20, and then we're going to multiply that by 1 plus 0.08. So remember, to get the decimal of that, you just divide this number by 100. That becomes 0.08. And then that's going to be 101.2 or 0.20, doesn't really matter, 1.08. Multiply those two together, so we're going to get the following. So that's going to be 109.30 or $109.30. And this would actually be the latest cost. So after it has been increased by those 3 amounts, we're going to end up with the new price, which is $109.30. Now, this seems like a very long process. So is there any way that we could have done this more in a quicker manner? So in fact, there is actually, because what we're essentially doing is we're grabbing this amount. So $88 is equal to this. So if we plug this equation here, so basically we're going to plug the original amount times 1.1, and now that's going to go in here. So basically we're going to get 1.1 times 1.15, and then if we plug this number into here, then we're going to be multiplying the same amount again by 1.08. And if we multiplied all those together, we would essentially get the same amount that we got here. But in that case, we would only need to do one calculation, and it's just in one line. So this is the quicker method of doing that. So it doesn't really matter in which order we perform the increases, because in the end, we're always going to end up with the same. Because if you notice here, since you're multiplying all these quantities together, you can alter the order of multiplication, and the answer will still be the same. Let's do some more examples with this to make sure that you get the concept. So say that we wanted to have something like this. So let's say a TV costs like $600. So it's going to be a small TV, obviously. And then it has a discount of 30% first. And then there's another discount that comes after that, which is, say, 25%. So we want to find out what is the new price of the TV. So remember, this is the discount, so we're decreasing the original value. So we're going to start with the 600. We're going to multiply that by 1. Now, since we're decreasing the value, we're going to subtract. So we convert this to a decimal by dividing by 100. That's 0.3. So this is going to be the value after it gets decreased by 30%. And then the same value that we calculate here is going to decrease by 25%. So we're going to multiply this whole thing by 1 minus 0.25. And then basically, if we just calculate that here, that's 600 times 0.7 times 0.75, and we can just plug this in our calculators and see what that gets us. So the new price of the TV is going to be $315. By comparison, we could try and think, okay, so is this a better deal than just having the TV at $600 initially and then doing one discount of 55% in one go? So would that actually give us the same value? Well, we can check here, because if we multiply 600 by 1 minus 0.55, which is 600 times 0.45, that would give us $270. So in fact, it would actually not be better than this deal. And you have to be careful with that, because a lot of shops will do this kind of thing where they discount a specific product once and they discount it again. But that's not the same as saying that we're adding the two percentages together and then just multiplying it by the original amount. We're actually just doing it in consecutive steps. So in essence, this value is going to be lower than that one. So this would be generally a much better deal than just doing those consecutive decreases like that. Now, let's say, for example, that you're given another problem that is a little bit more complicated, where it says that the cost of some car, so the cost of a car, or the price, is, say, $80,000. So it's going to be a pretty fancy car. So that's the original price. And let's say that this price increases by an amount of 5% per year. So we're going to write it as 5% per year. And let's say we wanted to find out what would be the price or the cost of the car after, say, 10 years. So how would we go about solving a problem like that? Well, you might think, okay, so if it's 5% per year, then if we have 10 years, we just multiply this by 10. And then that would become 50%. So all we need to do is we need to multiply this by 1.5, and that would give us the new value. That, however, would be incorrect, because what is happening is you're grabbing the original amount, so let's call this amount A, then you're increasing it by 5%, which is essentially multiplying this by 1.05. Then you're grabbing this amount, so let's call this one A1. Then A2 is going to be equal to A1 times 1.05, so you're increasing it on the second year, you're increasing it by 5% again. And if you notice something here, A1 is actually equal to this. So if we substitute that in here, that's going to be A times 1.05 times 1.05. So that would be the new price at the end of 2 years. And then if we continue this, this is going to be A3 is going to be the amount A2 times 1.05, which is the same as A 1.05, 1.05. So this amount times 1.05 again. And this is going to keep repeating. Now, if we want to find out the amount or the price or the cost of the car after 10 years, so that would be A10, then what do you notice here? So the pattern is this is going to be original amount A, and that's going to be times 1.05 squared. So the amount after 2 years is this value squared. The amount after 3 years is A 1.505 cubed. So we could actually guess that this would be the original amount times 1.05 to the power of 10, because we're essentially doing it after 10 years. So essentially what we do is we plug in our $80,000 here, multiply by 1.05 raised to the power of 10. So if we put that in our calculator, to the power of 10, and this is actually going to be equal to $130,311.57. So if we had originally just added an extra 50% to that, the amount would have been something like $120,000. But because we're essentially just adding an extra 5% each year, then at the end of the 10 years, we're actually going to end up with more money than if we just added the 50% together in one go. So I guess that's the main difference that we need to be aware of when we're dealing with problems like this ones. You need to really read the question and see what it is asking from you, because it is never as simple as just saying, oh, I just multiply the 5% by 10, that gives me 50%. It's never like that. So you need to really think about how you're going to solve the problem. But in general, it's just going to involve some kind of sequence like this. So something is going to be increased by this amount of money, and if you increase it by that same amount, this amount of times, this is essentially what you're going to get after that.